Okay, this is it everybody. 5.7, solving any linear equation. You can do them all now. You've got all the steps you need. So it's the same steps as before. I actually don't have a new step for you, mercifully, but I am going to write them all down for you again. Crazy, right? I know it's annoying. So I tried to do it a little bit different this time. Kind of focus on a few things. So the first thing you're going to do is you're going to clear fractions. And you're going to do that by multiplying by the lowest common denominator. That's what we did last time, and we're going to focus on this one as well today because we're going to do more complicated ones. Second step you're going to do is you're going to eliminate brackets by using the distributive property. And we did not do this last time, and that's why this lesson is a little different than last time, because we're going to clear brackets and then still have to eliminate brackets. We skipped step 2. We didn't have to do step 2 last time, but today we will. Okay, step 3. You're going to combine like terms on the same side of the equal sign, right? Going to look on both sides, see if you can combine some things together. Step 4, move all the variables to one side. And remember, when we do that, we're going to usually, not always, but usually we're going to add or subtract the smaller amount. Usually we'll focus on the smaller amount. Step 5, you will isolate the variable. This is a step that started us all off. It's the ultimate goal. Get that variable, that letter, all by itself. And remember, always add or subtract before you multiply, divide. And the last step is to check your answer. And the way you do that is to substitute it back into the original equation. Now, I imagine you're often going to skip that step. I'm going to skip that step today because it just takes so much time and effort to check your work. It's almost not worth it. It's just better to do a good job and be super careful when you're answering the question. Alright, so the first thing it says to do in this rather difficult looking question is to get rid of the fractions, because we do have fractions here, by finding the lowest common denominator. And the lowest common denominator of 4 and 3 is 12. Now, because this m plus 3 is all over 4, it's like it's one term right there. There's a term. And this 2m plus 1 is all over 3, so that's a second term right there. There's only 2 terms here. I know that's confusing. What a lot of people want to do here is they want to multiply by 12, by 12, by 12, and by 12, because they know you multiply every term by 12. But in this case, because it's over 4, this whole thing's over 4, you only need to multiply this whole thing by 12, basically multiplying all that by 12, and also multiply this whole thing on this side by 12. You don't need to put the brackets yet. You will eventually, though. Okay, so remember, once we've multiplied by the lowest common denominator, we'll know that we did it right when the fractions disappear, when we have no more fractions. So let's see if it works. Let's ninja slice here. 12 and 4, you can divide them both by 4, so you get 1 on the bottom, but what's the point of putting the 1s, right? Let's just leave the 1s off to make it look a little cleaner. So you get 1 on the bottom, and 12 divided by 4 is 3. And over here, 12 and 3, divide them both by 3. 3 divided by 3 is 1, no need to write that, and 12 divided by 3 is 4. Now, you see, this 3 is multiplying all of this, the whole thing on top. So this is why you now need to do the distributive property. What you now have is 3 times m plus 3. And on the other side, you have 4, and it's multiplied by this whole thing. You're multiplying by 2m plus 1. Great. So we've gotten rid of our fractions, which is nice, but we still have brackets. So you want to use the distributive property. You want to do mountains, feed the chickens, expand, whatever thing you want to call it, you got to do it. So 3 times m is 3m, and 3 times positive 3 is positive 9, equals 4 times 2m is 8m, and 4 times 1 is 4. Do we have like terms over here? No. Do we have like terms over here? No. Do we have m's on both sides? Yeah, we do. We want to get all the m's to one side. So let's take the smaller one, the 3m, and subtract 3m from both sides. So you end up with 9 equals 5m. When you do 8 minus 3, you get 5m plus 4. We're down to our last step, besides checking, which we probably won't do. We want to get the m by itself. So look for adding or subtracting first. Let's minus 4 and minus 4. So we get 5 equals 5m. Last step, this is 5 times m, so we'll do the opposite and divide by 5. We end up with 1 equals m. And that's the answer. We did it. Tough question. And guess what? They're going to get tougher. So the next one here, we need to look for the lowest common denominator of 3 and 4. Well, just like last time, I should be a little more original here. The lowest common denominator is 12. So again, this is really what we have written here, this 1/3 out front. This is just another way, don't write this, but it's just another way of writing this. It's exactly the same question more or less as we did over here. And this here is the same as writing this. If you find it easier to write it like this, you certainly can. But these are going to come up a lot, so I'm going to keep it like this for now. So again, this is very difficult at first, but when we multiply by 12, you only need to multiply this by 12 just one time. You don't have to multiply this by 12 and this by 12 as well. Because this 1/3 is multiplying by the x minus 1, this is all considered like one giant term there. So you only have to multiply that term by 12, and on the other side, again, this is multiplied, so it's like this is one big term, so you only have to multiply that whole big term by 12 as well. Because we're going to ninja slice. So 12 and 3, you can divide them both by 3, that becomes 1, no need to put it, and 12 divided by 3 is 4. And over here, 12 and 4, divide them both by 4, so that becomes 1, no need to put it, and 12 divided by 4 is 3. So what are you left with? You're left with 4 times 1, well that's 4, and you still need to multiply that by x minus 1. And on this side, you have 3 times 1, which is 3, and you still have to multiply it by x plus 2. Okay, we're back to a question where we have the distributive property. We got to get rid of the brackets. So we can quickly do that. 4 times x is 4x. 4 times negative 1 is negative 4. 3 times x is 3x. And 3 times positive 2 is positive 6. Do we have like terms? No, not on this side. And no, not on this side. Oh, come on. I want to do a question with every step in it. We'll get there. So let's get all our x's to one side. The smaller amount is a 3x. So I'm going to subtract 3x from both sides. Well, you got to love this. 4x minus 3x is 1x, but why not just put x? That'll save us a step. 6 is left on this side. The only thing left to do is add 4 to both sides, and you get your answer. X equals 10. Okay, getting harder and harder as we go along here. This first one, I see the only denominators we have here are 5 and 5, so I assume the lowest common denominator is 5. I guess I can still write it over here. LCD equals 5. So we're going to multiply this whole thing. This is like one term. We're going to multiply that by 5. Yes, we need to multiply the 2w by 5, and we also need to multiply this by 5, this 8 and 1/5. But wait a minute, 8 and 1/5, that's looking problematic, don't you think? So you're going to be multiplying 5 times this mixed fraction. But what do we have to do when we have mixed fractions and we're multiplying? You have to, like have to, switch this mixed fraction into an improper fraction. So let's do that. 8 times 5 is 40, plus 1 is 41 over 5. I'm just going to write that there and get rid of this. I've just rewritten that, okay? Okay, now we can ninja slice. We have a 5 on top, 5 on the bottom. That becomes a 1. This also becomes a 1. There's no need to put either one of those numbers. Okay, here, there's no denominator, so we're good. And here we have a 5 on top, 5 on the bottom. Again, we can cancel them both and put 1 and 1 if you want, but no need. We're looking good here. So, what are we left with? We're left with negative 3w minus 2. Then we have this 5 times 2w, which is 10w. And over here, the only thing we have left is 41. Great. So we got rid of the fractions. That was the first step. Second step. Do we have any brackets to get rid of? Yeah, we do. Right here. So let's expand that. Negative 3 times w is negative 3w. And negative 3 times negative 2 is positive 6. Plus 10w equals 41. Next step. Do we have any like terms? Yes, we do. We have this negative 3w and this plus 10w. So negative 3 plus 10, you have more positives, and you have 7 more. So 7w plus 6 equals 41. Do we have variables on both sides of the equation? No, we don't. So we got to get this w by itself. Why don't we subtract 6 from both sides? 7w equals, that's an ugly 41, but it's 41 minus 6, which is 35. And finally we divide by 7, and we get that w equals 5. Good job. The only denominators I see in this are 3 and 6, and the lowest common denominator of 3 and 6 is 6. So again, this is one giant term here because we're multiplying, so you're going to multiply all that by 6, and this is one giant term here because you're multiplying, so you're going to multiply all of that by 6 as well. Sorry, 6 here. So let's simplify. 6 and 3 will that becomes 1, and 6 divided by 3 is 2. And here you have 6 and 6. Well, those just cancel out completely. There's nothing left to do. So be careful. Over on the left-hand side here, you have 2 times all this. Let's do the 2 times 2 part first. 2 times 2 is 4, and we still have 5m plus 3. And over on this side, we have negative 1, and then all this part in brackets. Can we do mountains here, distributive property? Yes. Here and here. So 4 times 5m is 20m. 4 times 3 is 12. Negative 1 times 3 is negative 3. And negative 1 times negative 5m is plus 5m. Do we have like terms? No, we don't. Do we have terms on both sides? Yes, we have 20m here and 5m here. So let's take the smaller one and subtract it. Get rid of it on this side. 20m take away 5m is 15m plus 12 equals negative 3. Got to get that m by itself. Why don't we subtract 12 from both sides? So 15m equals negative 3 take away 12. That's the same as plus negative 12. They're both negative, so it's going to be negative. And you have 3 negatives plus 12 more is 15 negatives. Last step is to divide by 15. You get m equals negative 1. Okay, we got a bunch of denominators here, 4, 8, and 8. Well, the lowest common denominator of those numbers is 8. So we have to multiply this by 8, that being this whole term here. This is another term here, and this is a third term here. We have 3 terms, basically. So 8, 8, and 8 is what we have to do. Let's ninja slice. 8 and 4, divide them both by 4, you get 1, which I'm not going to write, and 2 here. 8 and 8 just cancel out completely, and 8 and 8 just cancel out completely. So what do we now have over here? We have 2 times 3, which is 6, times the 2x plus 3. Those cancel. We just have negative, or take away 7x plus 6, and this is still negative 3. So you're going to have to do mountains 2 times here. You get 6 times 2x is 12x. 6 times 3 is 18. Now you have negative 7. Don't forget, you have to take the sign in front. Negative 7 times x, which is negative 7x. And negative 7 times 6 is negative 42. And it equals negative 3. Do you have like terms? Absolutely. You have 12x and negative 7x. 12x take away 7x is 5x. And you also have 18 take away 42. Ooh, that's not easy. 18 take away 42 is the same as 18 plus negative 42. You definitely have more negatives. And how much more is 42 than 18? It's 24 more. I know that was a tough one. That equals negative 3. Again, we don't have variables on both sides. Darn it. So we can go straight to isolating the variable. Add 24 to both sides. So we're left with 5x. Negative 3 plus 24. You have more positives and you have 21 more. And then if we divide by 5, you'll end up with a fraction, which is very common with these. You get 21 over 5. You could write that as a mixed fraction. 4, because 5 goes into 21 4 times with 1 left over, or put it in your calculator and you'll get 4.2. Those are your possible answers. Okay, this last one, this will be the second time I'm trying it. Got it wrong the first time. This is hard. Every step involved here, and you can see it's a pretty crazy question. So the first thing we have to do is get the lowest common denominator. We have 2, 3, 4, and another 3. So basically you're looking for the lowest common denominator of 2, 3, and 4. And that is 12. So you're going to have to multiply 12 by a lot of things. 12 for this first bit here, that's one term, big term. 12 for this big term here. 12 times the 3, 12 times the 2n. 12 times this big term here. And 12 times the 2/3. Wow, that's a lot. So let's do our ninja slicing. We've got 12 and 2. That's going to turn into a 1, isn't it? We want all these denominators to be 1. That's basically the goal. So divide by 2, you get 1. Divide 12 by 2, you get 6. 12 and 3 this time. Divide by 3, you get 1. Divide by 3 here, you get 4. No denominator here, no denominator here. 12 and 4, divide by 4 and you get 1 on the bottom. Divide 12 by 4 and you get 3. And 12 and 3 we already did. If you divide them both by 3, you get 1 on the bottom, and 12 divided by 3 is 4. Okay, where are we at now? Let's see. We have 6 times 5, which is 30, and we're going to multiply that by negative n minus 6. Then we have 4 times all of this, the 4n plus 2, minus 12 times 3 is 36, equals 12 times 2n is 24n, minus 3 times 3, I missed this 3 when I did it the first time, whoops, 3 times 3 equals 9. I had a 3 there, but it should be 9, because 3 times 3 is 9, and you're going to multiply that by 5n plus 2. And finally we have 4 times 2, which is 8, so minus 8. There are a lot of distributive property you could do here. Expanding, the mountains, whatever you want to call it. There's 3 different spots, so let's do that. We have 30 times negative n, remember that's negative 1, so 30 times negative 1 is negative 30n, and 30 times negative 6 is negative 180, plus 4 times 4n is 16n, and 4 times 2, positive 4 times positive 2 is positive 8, take away 36, equals 24n. Negative 9 times 5n is negative 45n, and negative 9 times positive 2 is negative 18, and we still have a minus 8. And now we have all sorts of like terms. With our n's, we have negative 30n and 16n on this side. So we have more negatives, it's going to be negative, and 30 is 14 more than 16. Then for our constants, we have negative 180, positive 8, and negative 36. Oh my gosh. Well, negative 180 plus 8 is negative 172, and then we have to take away another 36, which is the same as adding a negative 36. So 2 negatives make it negative when you add, and 172 and 36 together is 208. So you have negative 208 there. On the other side, you've got 24n and negative 45n. Again, you can add the opposite if you want. You end up with more negatives, and there's 21 more. And finally, you have negative 18, take away another 8, which equals negative 26. Alright, let's get our n's to one side. I have negative 14 here, negative 21 there. Negative 21 is smaller, so let's get rid of that by adding. Do the same to the other side. What do you have more of here, negatives or positives? Positives. How many more? 7. So 7n minus 208 equals negative 26. Got to isolate that n. Let's start by adding 208. Okay, so we're left with 7n on this side. On the other side, more positives or negatives? More positives. And you're actually going to subtract here 208 minus 26, which is 182. Then you're going to divide by 7 on both sides, and something truly amazing happens. What happens is you get a whole number. 7 goes into 182 26 times. And why this is so amazing is I just made this question up. I just randomly threw a bunch of numbers, put fractions, put negative. I didn't think of this one bit, and then somehow I end up with an actual whole number. I love this. You can't understand how happy this actually makes me, and I'm not joking. Alright, so there you go, people. If you can answer this question, this last one that took me 2 tries, then you can pretty well answer any linear equation there is to answer. So good for you. You made it. And if you're having troubles, let me know. I can help you out. See ya!